Okay, here's a question starting out with a probability bit about disks. We've got, assuming you've read the bit at the top, to get the probability the two disks selected are the same colour, and they tell us the answer to show that question. Now you could do a tree diagram for this, but there are four possibilities in terms of the colours for each disk, so you might simply just want to split this into cases that work. So for example, you might start by working out the probability of getting a red and then another red. In order to do that, you use the fact that 4 out of 10 are red initially, and you've got to pick up that this is without replacement, so you're going to be having 4 over 10 times the number of red disks that are left over the total number that are left, so that's 3/9. And then you've got to do that the same way for the other three colours, add them up and you should get 2/9. If you can do that, you shouldn't have too much probability, too much problem with the probability that one of the two disks, exactly one, is blue. Okay, you can just break that down into two possibilities, I think, and add up together two probabilities. Moving on to part B, now we've got the situation above, but now different things happen according to whether the two disks are the same colour or exactly one is blue. So there are three possible outcomes. This is David paying Joanne, so that's your clue about what you need to do with the 45p. It gives you this nice advice. The probability distribution is in the form of a table. There are going to be three different outcomes, each with a probability, and a lot of the groundwork's already been done. And then for this part here, we've got to get the expectation of x. It tells you the answer is 33, and that's where you've got to remember your method for the expectation formula, and that's in your formula book on page 11 if you can't remember that method. So look that up, and then on to part C. We've now, slightly confusingly, got a change to the game where the amount Joanne wins is given by this y here. But really all that's going on is we've got a new random variable that is a linear function of the previous one, x, from the earlier part of the question, and what you're being asked for is the expectation over 100 times the game is played. And so it's just teasing you a little bit there. It's a two-stage process. If you work out the expectation of y, then that will be what Joanne expects to win on one game. And the expectation of a linear function of x, you should remember how to get the expectation of something like 104 minus 3x. That's one of the basic rules from the chapter. Once you've got an answer for that, you've then got to scale it up to 100 games in the obvious way. And then finally, to get the standard deviation of y, giving your answer to the nearest penny, well, standard deviation, always on S2, think which is sigma squared. The standard deviation is the square root of the variance. So what you really want is the variance of y. Now to get the variance of y, you've really got two methods. You could actually go back and work out the expectation, the variance of x from the table you had before. So you got the expectation of x, you could use a standard method to get the variance of x, and then you could use this scaling. So when you know how to change the expectation of x to get the expectation of y, you could do the same thing for the variance of y. Or you could think of just getting a wholly new table for y based on this formula and working out the variance directly from that. Either method works, and it's up to you which one you use. Good luck with that question.